our unit on the rates of change. Today we're going to start with the average rate of change. So we'll do a lesson today, we'll do a lesson Wednesday and Thursday, and then Friday and Tuesday will be test days. And then next week, I'm going to finish up the guide on the Monday, and then you can write a test any other day during the week next week. Okay? So we're going to start today again with the average rate of change. So again, if I got in my car and I drove home after school, and I measured the distance from my house to Westmount, and I measured the time it took me to do that, then I could figure out on average how fast I drove home, right? I would take the distance that I drove and I divide it by the time that I drove. And that's the average rate of change, okay? But if I say I was speeding, so I wanted to get home, and there was a police officer with a radar gun, he's going to figure out how fast I was traveling at a particular moment in time. And that's the instantaneous rate of change. We're going to deal with that on Wednesday. Okay. So the first example to illustrate the average rate of change is a football is kicked into the air such that its height, h in meters after t seconds, is given by the function h of t is equal to negative 4.9 t squared plus 14t plus 1. So what that means is if I want to figure out the height of the football at any time, say I wanted to figure out how high the football was at 5 seconds, I would put 5 in for t, and that would give me the height of the football. So I want to determine the average rate of change of the height with respect to the time during the first 3 seconds the football is in the air. So my time interval is from 0 to 3 seconds. I want to figure out on average how fast is that football moving. So in order to figure out the average rate of change, I need to figure out how the height has changed. And in mathematics, we use a triangle, which is actually a Greek letter delta. So delta H means the change in the height. And I divide that by the change in the time. And this will give me the average rate of change. So to figure out the change in the height, I would need to figure out the height of the football at 3 seconds and subtract off the height of the football at 0 seconds. And that would give me the change in the height that the football went between 0 and 3 seconds. Does that make sense? And then I divide it by the change in the time. So the change in the time is 3 minus 0. So to determine the height of the football at 3 seconds, I substitute 3 into the height function. And to determine the height of the football at 0 seconds, I substitute 0 into the height function. And I divide that all by the change in the time, and the change in the time is 3 minus 0, which is 2. So using proper bed mass, you put that all into your calculator, and you would come up with the answer.
Attention please, could Mr. Fraser please contact the main office? Mr. Fraser, please contact the main office.
The approximate answer is negative 0.7 meters per second. Okay? So if I say on average the rate of change between the height and the time is negative 0.7 meters per second, that means the football is moving at a speed of 0.7 meters per second on average. Okay? What does the negative tell me? Okay? Right. Okay, so the football in this case on average is moving down. Okay? So together, when the negative and the speed becomes the velocity. The velocity tells you the direction and the speed at which an object is moving. Okay? Any questions on that? Okay. So pretty straightforward stuff in order to find the average rate of change. Really what you're doing is you're using that y2 minus y1 over x2 minus x1, right? You're taking the change in the dependent variable and dividing it by the change in the independent variable. So really what you're doing is you're doing that slope formula over and over again. Okay? So to illustrate that, example 2, determine the average rate of change of y with respect to x, given that y is equal to x cubed minus x minus 1 over the interval between x's from 2 to 4. Okay, so I want to figure out on average how is y changed when I change x. So I need to determine the change in the y's over the change in the x's. So to figure out the change in the y, I need to figure out y at 4 and subtract off y at 2, and that'll give you the change in the y over the change in the x's, which is 4 minus 2, right? Which is exactly the same thing as y2 minus y1 over x2 minus x1. It's a slope function. Okay? So to determine y at 4, I'd substitute 4 into my function. And to determine y at 2, I substitute 2 into my function. And I divide that all by the change in the time, which is 2. Okay, so that would be 64 minus 5 is 59. Minus 8 minus 3 is 5. Divided by 2, which is 54 divided by 2, which is 27. Just check my math, make sure that I did that correctly. Okay, good. So the average rate of change of y with respect to x, or the slope of the line joining from x equal to 2 to x equal to 4, would be 27. Okay, and pretty much that's about as easy or hard as the average rate of change is. And that's all we're going to do today.